we've got to put this expression into the form k cos theta plus alpha. This is an harmonic form question. I think it's worth writing down what k cos theta plus alpha equals. If I put that here, using the formula, this is k cos alpha cos theta minus k sine alpha sine theta. So if I divide k sine alpha by k cos alpha, I get that tan alpha must equal 480 divided by 140. Zeros obviously cancel, and if you look that up on a calculator, you get that alpha is equal to 73.7397, and on it goes. We also know that cos squared alpha plus sine squared alpha must equal 1. And if I multiply through by k squared, I get this. So therefore 140 squared plus 480 squared must equal k squared. Therefore, k is equal to 500. So they want alpha to 2 decimal places, so we can say that alpha is equal to 73.74. And those are the results for part A. So in part B, we have to apply our knowledge to a practical problem here, and it's the population of rabbits. Wouldn't you just know it? Okay, B. The number of rabbits is modelled by this equation, where t is months and a is a constant. And we're told that R max is equal to 1500. So using the work we've done in part A, I can transform this equation into this. Here's our value of k, and I've made this into theta plus alpha. So all we've now got to do is work out what the value of a is. Well, R max is 1500. Now what does the cosine waveform do? This goes from +1 through 0 to -1. So the maximum value of the cos term is 1, so the maximum value of this whole term is 500, which, if the population is 1500 max, we know therefore that a is equal to 1000. So the complete model is r is equal to 1000 plus 500 cos 30t plus 73.74. And that will be the answer to part B. So in part C, we're told that the actual number of rabbits is at a minimum value in the middle of April. Now that would be that t would be equal to 3.5. So we now need to compare this value with what the model will say. Now for the minimum to occur, we need our term to be -1. Now that occurs when the angle concerned equals 180 degrees. That's when the cosine waveform is -1, which means that 30t plus 73.74 must equal 180 degrees. And the value for t we get, if you work that out, is 3.542, which is well within the region of our expected value for the minimum population in April of 3.5. So the model gives a good result. When you get rabbits, you get foxes, and we're now told the number of foxes in the wood during the year is modelled by this equation. The number of foxes is at a minimum after t months. Find, according to the models, the number of rabbits in the wood at time t months. Okay, so here's our equation for foxes. So when is this going to be a minimum? Well, sine is at a minimum when the angle equals 270 degrees. So therefore 30t plus 70 must equal 270. So therefore t is equal to 20/3. So we now need to substitute this value of t into our equation for rabbits and see what turns out. Oh, I know this should be big T really. And if you put that into a calculator, you get the answer of 1032.61 rabbits. So do you count the 0.61 rabbits as a whole rabbit? I suppose you do. So this is 1033 rabbits. And that's the answer for part D and the end of the question.